Welcome to another physics class. During our last lesson, our topic is example to illustrate simple harmonic motion. And during that last lesson, we look at the second example, which is a loaded spiral spring oscillating up and down to perform simple harmonic motion. And when we concluded the lesson, I promised that we are going to take the last one today. And the last one we are going to look at is a loaded test tube placed on liquid oscillating simple harmonic motion. As I said, this lesson is a progressive lesson that takes from one topic to another. Therefore, if you want to enjoy the lesson to maximum taste, please try to like, share, subscribe, and when I upload a new video like this, you'll be able to get the notification and you get more understanding on the new topic. Today, we are going to look at a loaded test tube placed on liquid, how we can use this one also to demonstrate simple harmonic motion. From the diagram on the board, if you look at it, this is the test tube that have been loaded with a mass. So when you place the test tube on water like this, without any displacement, here now the displacement is taking place. Now, the length or the height of the test tube within the liquid is L. L is equal to length of the test tube in the liquid. Now, where this U is the upthrust of the liquid on the test tube. Then the weight of the test tube will act downward, while W is equal to weight of the loaded test tube. Now let's call this one A and this one B. Let's first consider A, when the test tube is gently placed on the surface of the liquid. Now the upthrust acting upward and the weight acting downward will be equal to the total force will be equal to U minus W equal to 0. And from that one, for this test tube to be in equilibrium, the upthrust must be equal to W. And mind you, the W is equal to mg. And don't forget, what we call upthrust also is a force, but it is force that a liquid will use to oppose the motion of an object placed on it and acting downward. So from this one now, mass, let's remove this mass because we don't need the mass of the liquid. We only need the density. We now say density, that is rho, is equal to mass over volume, where this symbol rho is equal to density of the liquid. If that is the case, then mass will be equal to density multiplied by volume. Come back here, it means our upthrust, which we said is equal to weight, will be equal to density multiplied by volume, then multiplied by acceleration due to gravity. That is when the test tube is gently placed on the liquid. Now, to consider the length of the test tube in the liquid, now say volume is equal to area covered by this test tube multiplied by length of the test tube in the liquid. Then we can now say our upthrust will be equal to density multiplied by area multiplied by the length or depth of the test tube in the liquid multiplied by acceleration due to gravity. So this one will be the upthrust equal to density of the liquid multiplied by the area covered by this test tube on the surface of the liquid. Then the L is the length of the or depth of the test tube within the liquid, while G is acceleration due to gravity. As I said, where rho is density of liquid, A is area covered by the test tube on the liquid. Then L, length of the test tube in the liquid, and G is acceleration due to gravity. For B now, when the test tube is displaced downward or pressed downward in order to oscillate up and down. For B now, the test tube is pressed downward. Now the new volume, as we said here, new volume will be equal to area multiplied by L plus S, where S is what? The displacement when the test tube is pressing downward. Now, if the new volume is equal to this one, then the new upthrust produced by the liquid on the test tube, mu, will be equal to rho, which is density of the liquid, multiplied by the area, then into L plus S bracket G. Or rather, it will be density multiplied by acceleration due to gravity into L plus G. So, the force acting downward, F, is equal to mg, which is equal to W. Now, from there, we can now say that the resultant upward forces, then resultant upward forces F will be equal to mu, that is the new upthrust, minus F. And the new upthrust, as I said, is equal to density multiplied by acceleration due to gravity multiplied by area into bracket F plus S, bracket close, minus F is what? mg. And don't forget, as we did the other time, our m is from density is equal to mass over volume. Then our m will be equal to density multiplied by volume. If that is the case, as we did the other time, our mass will be equal to density multiplied by area multiplied by length. So without wasting time, our F now will be equal to density multiplied by G multiplied by A into L plus S, then minus density multiplied by A multiplied by L into G. So, or rather, let's write it in this form. So it will be tallying with this one. That is density multiplied by G multiplied by A multiplied by L. So open this bracket. Then we are going to have our resultant upward for equal to density multiplied by G A L plus density G A S, then which is minus density G A L. This term, we cancel this term. So we can now say that the resultant upward force will now be equal to density multiplied by G A S. Now, the restoring force F, because we said this is resultant upward force, be equal to F is equal to minus density multiplied by G multiplied by A multiplied by L. Why is it minus? Don't forget the definition of restoring force, as we said in our former lesson. That is the force that will restore the particle or the mass from displaced point to its equilibrium position. Force that will restore the particle to its equilibrium position. So that is why it takes negative sign, because it's opposing the force that acting downward. So it will take negative sign, as we explained in our former lesson. Then the accelerating force. Accelerating force F will be equal to ma. This is restoring force. This is accelerating force. So equating the two together, we are going to have ma will be equal to minus density Gs. Therefore, the acceleration of a loaded test tube A will be equal to minus density Gas, then over L. That's the acceleration of a loaded test tube oscillating up and down to perform simple harmonic motion. That is, A is equal to minus density of the liquid multiplied by acceleration due to gravity multiplied by area covered by the test tube and the displacement over mass of the test tube. Now, since A is equal to minus density Gas over L, from there you can now say from general formula of simple harmonic motion, but A is equal to minus omega square S. Take this one together. This one and this one together, we are going to have minus omega square S is equal to minus density G S over L. Now from there, S will cancel S, minus will go away. So we are going to have omega squared will be equal to density G A over L. So the angular frequency or angular velocity of a loaded test tube on liquid will be given as omega is equal to density G A over M all into square root. That is the formula to calculate the angular frequency or angular velocity. Angular frequency or speed or velocity of a loaded test tube placed on water to perform simple harmonic motion. Now to get the period from general formula, period T is equal to 2 pi over omega. And we've said the omega is square root of density Ga over M. So let's now substitute for this one. So our T now is equal to 2 pi divided by square root of density Ga over M. And this one will now give us, period, will now give us 2 pi square root of M over density, acceleration due to gravity, and area. That's the period of the loaded test tube placed on water, oscillating up and down to perform simple harmonic motion. From the formula, we can now say that the period of a loaded test tube placed on liquid depend on 1. Mass of the test tube and the content. 2. The density of the liquid. Density of the liquid. 3. Acceleration due to gravity. And 4. Area covered by the test tube on the liquid. So these are the properties of period of a loaded test tube placed on water. I said 1. Mass of the test tube according to the formula. According to this one, then T will be directly proportional to the square root of M. When you consider density, T will be inversely proportional to square root of density of the liquid. At the same time, T will be inversely proportional to the square root of acceleration due to gravity. And the last one, which is area, T will be inversely proportional to the square root of area covered by the test tube on the liquid. So these are the factors that we are determining the magnitude of period of oscillation of a loaded test tube. And if we compare this one with that of simple pendulum, we say that is different. Compared with that of a loaded spiral spring, we say that it's different. Each system have their separate formula. That is the importance of all these formula, so that when you are now giving calculation, you now the correct, the suitable formula to apply. Once a given system is mentioned within that question. Let's take this one as example 1. A loaded test tube of mass 0.002 kg is placed on water and cover an area of 1.2 meters square. Calculate the 1. Angular frequency, 2. Or B. Period of oscillation, C. Length of the test tube when placed on water. Density of water is given as 1000 kg per meter cube and G is given as 10 meter per second scale. The first question, which is A part of the question, asks us to calculate angular frequency. And that one is omega, which is equal to square root of density of water multiplied by acceleration due to gravity multiplied by area cover, then divided by mass of the test tube. From the question, we were given mass M as 0.002 kg, area A as 1.2 meter square, then density of water is given 1000 kg per meter cube. The last parameter is G, which is equal to 10 meter per second scale. So put in all this, then angular frequency will be equal to square root of 1000 multiplied by 10 multiplied by 1.2, then divided by 0.002. Then angular frequency is equal to square root of 12,000 divided by 0.02. Now our omega will be equal to square root of 6 million. Then omega will be equal to, the answer will be 2449.48. This is angular frequency, rad per second. Now, the next question is B part of the question, which is period. Period, capital T is equal to 2 pi over omega. Note that this is the omega, and the omega has been calculated. So this one will now give us 2 multiplied by 3.142 as pi, then divided by 2449.48. That will be 6.284, then divided by 2449.48. Period T will be equal to 0.002565 seconds. Then that will be equal to standard form, that will be equal to 2.565 times 10 raised to power minus 3 seconds. That's the period of oscillation. Now, the last question under this one, question C, length of the test tube, on water. Don't forget, volume is equal to area multiplied by length of the test tube. From this one, the volume can be calculated by using density is equal to mass over volume. So density multiplied by volume is equal to mass. Volume will be equal to mass over density. And the mass that is given for us is 0.002 divided by 1000. So the volume will now be, the answer to this is 0.002 over 1000 will give us 2 times 10 raised to power minus 6 meter cube. Now from there we can now calculate L. L now will be equal to volume then over area. And the volume we got is 2 times 10 raised to power minus 6 over 1.2. Finally, L, length will be 1.667 times 10 raised to power minus 6 meter. That's the length of the test tube inside the water. Let's take this one as example 2. A test tube of uniform cross-sectional area 3 times 10 raised to power minus 4 meter square is loaded with lead salt placed on oil of density 700 kg per meter cube. If the total mass of the test tube is 0.15 kg, calculate the 1. Depth of the test tube in the oil. 2. Period of the oscillation. Now, from this question, like the one we calculated the other time, we have to calculate length. And we know that volume is equal to area multiplied by length. That is the depth of the test tube in the liquid is the same thing as length. So, but now volume is not given. So we still need to calculate volume by say density of the oil is equal to mass over volume. So from there you can now say density multiplied by volume is equal to mass. So we need volume. Volume now is equal to mass over density of the oil. And the mass of the mass of the oil is of the test tube together with the content is given as 0.15 kg. So that will be 0.15 over 700, which is the density of the oil. Volume will be equal to 2.14 times 10 raised to power minus 4 meter cube. Now from there, we can now calculate the depth, which is the length. Area is given. Area on the question is equal to 3 times 10 raised to power minus 4 meter square. So length now will be equal to volume over area, which will be equal to 2.14 times 10 raised to power minus 4 over 3 times 10 raised to power minus 4. Taking this one up, so we are going to have 2.14 over 3. By the time we take this one, or minus 4 plus 4 will be equal to 0. So we are now left with 2.14 divided by 3. And length will be equal to, the answer will be 0.7133 and so on. That will be meter. The second question, which is part B of the question, says you calculate period T, and period T is equal to 2 pi into square root of density multiplied by A multiplied by G then over N. That's the formula for period. Now, this one will now give us T will be equal to 2 multiplied by 3.142 into square root of, what is our density given? 700. What is our A? That's, according to the question, 3 times 10 raised to power minus 4 times 10 raised to power minus 4, then multiplied by 10. Then divided by, what is the mass? is 0.15. The period will be 6,284 multiplied by square root of 2.1 divided by 0.15. This one will now give us 6.284 multiplied by 14, and t will be equal to 9. That one will be root 14. Then t now is equal to 23.512 seconds. 23.512 seconds. That is the period of its oscillation. And that's all for the example 2. Now, take this one as example 3. A loaded test tube of mass 1.5 kg placed in a liquid of density 0.0095 kg per meter cube was made to oscillate vertically when slightly pushed down. If the time for 50 oscillation is 35 seconds, calculate the 1. Periodic frequency, that is A. B. Angular velocity. C. Length of the tube below the liquid surface before it was displaced. Now the first question says we should calculate the periodic frequency. A. The word periodic frequency is the same thing as frequency, which is equal to 1 over capital T. It is being called periodic frequency because of this period. Mind you, from the question, period is not given, but from the parameter given in the question, mass is equal to 1.5 kg, then density of the liquid is equal to 0.0095 kilogram per meter cube. Then time, number of oscillation is given. N is equal to 50 oscillation. Then time for 50 oscillation, small t, is given, 35 seconds. So using this one and this one, we can now say that t will be equal to, that is time small t over n. That is time to complete 50 oscillation over number of oscillation. That one will now give us 35 over 50. Now, capital T equal to 0.7 seconds. That is the periodic frequency. We have to calculate the periodic frequency. So our F now is equal to 1 over 0.7. So 1 over 0.7 will give us, that will be 1.4285 hertz or per seconds. That's the unit of frequency, hertz. To calculate angular velocity from the parameter given on the board, so omega will be equal to 2 pi over capital T from the parameter given. So we can now say that is 2 multiplied by 3.142 is divided by 0.7. This one will be 6.284 divided by 0.7. The omega, which is angular velocity, is equal to 8.977 rad per second. Now, to calculate the length of the tube below the liquid surface, we said the other time, that's question C, volume is equal to area multiplied by length. Now both area and volume were not given. So let us calculate volume. So volume from density is equal to mass over volume. So density volume is equal to mass. So volume now will be equal to mass over density. So the mass given is 1.5. That will be 1.5 then over 0.0095. So the volume now will now be equal to, now that will be 157.894 meter cube. That's the volume. Now the next thing is to calculate area. To find the value of A from omega is equal to square root of density multiplied by area multiplied by G over M. Let's make A the subject of the formula. So taking the square of both sides, we are going to have omega square be equal to density AG over M. This one will now give us M omega square be equal to density AG. So A now be equal to M omega square over density multiplied by G. And the mass that was given is 1.5. So A now will be equal to 1.5. The other time we've calculated omega as 8.977 square 8. Then divided by density, according to the question, that is 0.0095. Then multiplied by acceleration due to gravity 10. Now, this one will give us 120.879 divided by 0.095. Then A now will be equal to, now this one will now give us 1272.41 meter square. Now from there, we can now calculate the length. So our head now from this point be equal to volume over area. So this one will now give us, the area calculated here is 157.894 divided by 1272.41. So length will now be equal to, so the length will be equal to 0.1240 meter. That's for question number C of example 3. Now, this is the convenient point to stop on this example also, that is example to illustrate simple harmonic motion by using a loaded test tube placed on any liquid. And if you still have questions on any one that we've done, maybe for today or the previous one we have done, please, you can ask your question from the link under the channel. And as I said earlier, if you are just joining us, to enjoy this lesson in maximum rate, please try to like, share, and subscribe so that our previous lesson, you'll be able to see it and watch. Thank you.